Sorry.
Everybody, okay, today, and less people here. Yeah, like usually have this kind initially in the morning was okay, but in the middle of our time is increasing. Now, finally, we have less number of students. So you like to send out board or block teaching? We can every week and 3 hours, 2 hours. Or we like to have this kind of whole day, whole half day. Teaching this one, do you like it?
I think for this topic, the blog was pretty good to have like a fixed topic and then write a second about it. So I think that is one of the.
What you want to say, let's make it. Yeah. That's it. Anybody very tired? You're tired because you are trying to do so many things. Do game and trying to other side. Trying to his lectures. That's why he's very tired, but he's very multitasking person. Yeah. Okay, so now we can Brine mining, right? What kind of brine mining do you want to extract from seawater? What was the favorite to extract from seawater? What do you want to extract from brine? So, yeah, from seawater brine. You know, after our rivers was flooded, so we have a lot of high concentration of brine. Chlorine, you want to extract chlorine. How about you? You don't know. Okay. You don't want to extract anything. How about you? Pure water. Okay, pure water that we extracted. So we are talking about salt, the minerals. What is inside the brine? So what kind of yeah? What? Sodium chloride. Why do you want to extract sodium chloride? Ah, you want to in the two, right? All right. Okay. Lithium. Okay. Lithium. Okay. Seawater contain lithium. So sodium chloride, lithium. How about you? Gold. Do we have a gold in seawater? What's the concentration? No? Ask AI. Ask open chat AI. Ask them, what's the concentration of gold in seawater? So if you like to recover gold in seawater brine, so he's asking what's the concentration? Almost nothing. Yeah. Almost nothing. Okay, there is a gold. Yes, still there. Yeah. Still there. How about you? Lithium. Okay, lithium. Okay, lithium, gold, sodium chloride. How about you? Silver. Diamond. Opal or aluminum. Okay, aluminum. What's the concentration of aluminum? Ask AI. Don't ask me. AI. is smarter than me, yeah? What do you like to extract? Magnesium, calcium. Okay, that's the good medium. That's good. How about you? Carbon dioxide. You may expect carbon dioxide from CO2. Oh, it's faster good. But like we inject the CO2, so that's why you want to extract. First. Sodium chloride. Oxygen. Oxygen. Okay. Oxygen. That's good. That's good. How much the concentration?
It's
0.1 million ppm. 0.01. Aluminum is 0.01 milligram per liter. Okay. Seawater contain everything. Or iron was silver and lithium and sodium chloride, everything there because seawater was for 4. Almost billion years ago. So we have a lot of minerals already from the sea that they stay in the seawater. The difference will be if we did the heavy metal like the aluminum or gold, so they are already settling down under the sea and the sediment because it's heavy. For sodium, chloride, sulfate, magnesium, calcium, they are still very high concentration in seawater. Okay? Also lithium, rubidium. So there are many materials we can recover. Yeah. How? How? You can put what's the concentration of copper? There is some copper concentration, but not many because of copper was heavy metals. So they are easily settling that. What's the concentration? Copper is around 10.5 milligram per liter. Okay, 10.5 milligram per liter. So many years, a lot of minerals already dissolved in seawater. So most of seawater, they have a mineral. So this mineral, we can recover from brine because we just extract only water and then discharge to the back to ocean, right? So in this case, this is not efficient to have a more mineral recovery we can try to collect. And then this can make a more beneficial right? So you can see that this diagram. Can you read? It's very difficult to see, right? So there are many minerals. Copper, magnesium, calcium, lithium, bromine, rubidium, potassium. Potassium is one of the two fertilizers, right? Magnesium, calcium, iron. Yeah. So this is the concentration in Gulf seawater, right? So which means this is the almost 10 ppm, 1 ppm. So we have a 1 ppm, more than 1 ppm, or more than 0.1 ppm is possibly we can collect. How about this one? This is the price of the US dollar per 1 kilogram. Yeah. So which means, so what's the highest value? White gold, AU, is almost $100,000 per 1 kilogram. Right? How about next, rubidium? It's almost $10,000 per 1 kilogram, right? Yeah. So can you? So how we can make it sure this kind of recovery of the useful mineral rather than discharge to the ocean. So your assignment grade, one of the question is about brine mining. How you want to do brine mining, right? How you want to do that? So why not discharge to the ocean, or why not just collect the mineral before discharge to the ocean? So what do you prefer? The problem is that in Australia, okay, we are discharging to the ocean because there is not a problem with the environment. But if you think about Middle East, like a Gulf Sea or Red Sea, so they are keep increasing the temperature of the seawater, and then Brine keep discharging to the Red Sea or Gulf Sea. So they are little bit contained condition, right? So you have a increasing number of salt, yeah, very high concentration. So still they are increasing. Then you have a lot of environmental impact for the brine discharge, and you will have a lot of issues with the discharging. So we like to recover brine. So how we can recover brine? So most of them, okay, let's say very, very low concentration, 0.1 milligram per liter here. So most of them are very low. And then you can have a 0.1, and you can see what's the price? 1 kilogram, $1,000, $10,000, $100,000. So if you collect your white gold, AU, in seawater brine, the concentration is almost to 0.00001 ppm. So is it worth to recover white gold in seawater? Or you have a rubidium chloride here, almost $10,000 for 1 kilogram. So you have around 0.2 milligram per liter in seawater. How about lithium? Now the lithium battery is very much popular. Yeah. The lithium concentration in seawater is around 1 milligram per liter. So if you collect 1 milligram per liter in seawater, one kilogram is $10. So which means when you treat the 1 ppm and 1,000 liters, yeah, 1,000 liter, 1 ppm, so you have a 1 gram. Yeah, 1 gram. So 10,000, 100,000 liter. So you will have a 1 kilogram, $10. So as I mentioned, Sydney desalination plant, we need to have a 250 million liters per day. So how much we can collect from seawater? Every day, how much lithium we can recover from seawater? So how much water? 1 kilogram is $10 for the lithium concentration. So how much you can collect from Sydney desalination plant? So you can think about this concentration versus Sydney desalination, 250 million liter. So which means very high concentration. Yeah, you can collect, you can get a lot of value out of it from your seawater desalination. So that's how we have to think about brine mining, because what technology, and then your assignment, you have to think about economic value. Like considering desalination plant, after you desalinate it and then you design, yeah. So you have to think about what kind of brine mining will be the economically viable or technologically possible, and you have to propose in your assignment 3. Yeah. So we have to think about. So this red color, red zone is the most probable zone for our brine mining. The rubidium concentration is 0.2 milligram per liter. So you have a $10,000 value. So the lithium is 1 milligram per liter, and you have around $10. How about bromine? Bromine is also high concentration, almost 100 milligram per liter, and then $10 per kilogram. How about others like magnesium? So you want to recover magnesium. So magnesium value is $10 for 1 kilogram. So see what your concentration of magnesium is very high, like almost 2,000 milligram per liter. Yeah. So you can easily convert what's the production and then what's the value, then what's the technology, what's the economics, what's the technology viability. So that's the briefly you can review and then select best way to recover some of the material for resource recovery brine. So that's the assignment 3. You need to answer, and then you will have a good marks if you give a very good business model or business modeling related report. So that's the you will have a very high marks for your assignment 3. Yep. So let's just see. Anybody recovering seawater brine at this moment in the world? So you mentioned about salt, sodium chloride. So in anybody recovers sodium chloride from brine? Yeah. Where? Where? In Kenya. Kenya. In Kenya. So is it brine or seawater additives? Is our brine or seawater additives? Seawater. We are talking about seawater, right? Seawater, not the our brine. Yeah. Okay. So there are a lot of people right now because also they derive from seawater. Yeah. So what's the difference? So you have a lot of salt. So your salt is from where? So you have a table salt there from, right? So what kind of salt do you use? Where is this from? It's a genuine. How about you? Where is the table salt from? Still have a sea salt. Sea salt, right? Yeah. From where? Which is sea salt? They have salt plants. They have like evaporating basin. Okay. And they'll get the seawater and where? So where? I don't know where. Don't know. Actually, everybody knows. Yeah, everybody. Yeah. Right. Okay. Salt. Yeah. From Himalaya, like pink salt, right? So you need to enjoy the Himalaya, Nepal. Anybody from Nepal here? No? Nobody? Are you from Nepal? So you have a pink salt, you have a salt store, right? So you're selling a lot of Himalaya pink salt in the world. So you can buy it from Pulse or Ural, pink salt, because this taken from the algae. The pink color of the algae they grow and then they create the salt as the salt. And then people just mining and grinding and just selling because people are saying that this is good for health. Yeah. Super X. Okay, that's the one of the very famous salt. How about anybody, yeah, bring the sea salt here? But anybody knows where is this sea salt from? How they create this sea salt? Yeah, so where is this from? So nobody knows, right? Even though you are drinking, and oh, you know where?
From the sea by evaporating all the
Oh, okay, which area? Which sea water? Which is sea water?
Yeah.
Out of Vietnam. Right. The impact, if you go to the coast and forest, so there is a very famous brand of table salt. Like Sasa, Sasa, Sasa? SAXA, like the pink color, very, very big one, yeah. But they have a Sasa SAXA, Sasa salt. So this salt is from seawater. So every seawater was very big from different places because they have a different way. So it's not like every salt seawater. So there are many different compounds. Like the first precipitation is not salt. But the first precipitation will be calcium carbonate or some magnesium carbonate. So they have to remove some of the salt, like a crystal. Then they have to collect sodium chloride, which is the main salt, right? So there are many different way of the production. But so far, we haven't really produced any even table salt in the dry because people use anti-stallant, people use some chemical, people use some material inside seawater and the pre-treatment, our processing. So they don't have our dry even any dry mining. But do you know that Saudi Arabia, New City? Yeah. Yeah.
Long City, that's my hometown.
Your hometown, New City, right?
So,
All right. So,
yeah.
okay. So you're from Saudi Arabia. So New York City has a very ambitious planning for the future generation development. This is one of their proposal, like brine mining using the seawater desalination. Right. So it's still now it's a lot of construction is going on there, right? So that's what they would like to develop. They want to produce this stone and brine mining from the New York City, the world's largest desalination plant, 1 million cubic meter per day. The largest desalination plant they want to produce, and then this is their technology. So they want to collect all the brine, and then they want to develop the membrane, brine concentrator, and crystallizer. Also, they like to have a bromine production line, and they want to develop the sodium chloride, 25% of the salt. Also, they want to produce the crystal salt, sodium chloride, crystal salt, and then they want to also produce the bromine. So that's currently the most active brine mining project at this stage. But there is no such a way to have a brine mining, so that this brine mining is the future. Our also target. We may have to think about how we can create the opportunity. So this is the mineral recovery from bromine. How the people collect the magnesium or different salt, and you can see the ocean provide more than 40% of the magnesium. So already, magnesium is well recovered from ocean. So 1 kilogram of the magnesium is around $10. So they are also selling the magnesium in the world. So you can see this is the 1/3 of the world supply salt come from sea. It's not from the Arab brine. Arab brine has a little bit of chemical, little bit of treatment. That's why still we haven't really recovered any even salt, even though there are a lot of salt. But and now is cooking salt, table salt, and then we have also base for various agriculture fertilizer because potassium can be a good fertilizer, and bromine practically unobtainable from land mineral iodine. So bromine cannot be obtained the land mining. So a lot of people they collect the bromine from Dead Sea. The Dead Sea concentration of bromine is very high. So they try to collect the. So you can see it's not the out of brine. It's more of a seawater as it is. So there are many brine. The seawater related. So you can see number one is the cooking salt. So in Australia, most of cooking salt is produced from this area near the Adelaide, in the south area. And then you can see the number three is magnesium. So there is also magnesium uh, manufacturing company from seawater, especially the south area. Also, we have one more, the cooking salt near the west north area, this area. So that's the most of the cooking salt from Fasa or Australia made sea salt from this area. And if you look at the worldwide, so you can see a lot of sea salt production line in Asia, Africa. I also in South Africa, South America area. And you have also potassium and bromine. They are collecting from seawater, especially the bromine concentration is very low in seawater. It's around 50 milligram per liter. But Dead Sea has more than 50, like 100, 200 milligram per liter. So the bromine mineral mining is happening in Dead Sea area because they have a very, very high concentration of salt. So that's the way, only they focus on the seawater, not the brine. But now is we need to look at the circular economy. The brine has a very high salt water. Then you have to collect the effective way of your sea salt as well as potassium, magnesium, and bromine. So in the future, we need to think about desalination plant. More and more, we are increasing their capacity. Now, brine is more produced. Yeah. So this brine can be also recover some of the useful mineral for the world. Sea salt, brine salt also possible. Bromine, magnesium, potassium as a fertilizer can be used as a good mineral sources. So how we can combine this one? And so this is also a little bit of water chemistry you need to think about because you need to precipitate. What's the separation mechanism? Because of sodium chloride is a very small molecule. How you can separate this also precipitate. And you can see the precipitation concentration, calcium carbonate, when you have a 50 ppm, then they have a very good way of the gram per liter, 50 gram per liter, and they will get the precipitation first. And then calcium sulfate. So when you have seawater, so you collect seawater, and then you can boil or you can just leave as it is. So you will start to dry your water molecules keep evaporate in your room temperature. and then you will see the precipitate. The first precipitate is calcium carbonate in your seawater, followed by calcium phosphate, calcium sulfate, 70 gram per liter, and then sodium chloride is next, 100 gram per liter. So that's why reason when you have a sea salt doesn't mean you have a lot of calcium, magnesium, or other component, because different mineral has a different their precipitation concentration. That's the reason why it depending on the your controlling the concentration of the your salt and then precipitant material, you can control. So if you want to get the very high sodium chloride, so this level 100 gram per liter precipitation is the best way. So you don't have to go for this level below 70, also more than 250, because they will mixed with the magnesium sulfate, potassium chloride, and magnesium chloride. So you need to look at their solubility of your product, and then you can slowly, that's the how, if you see the like a very expensive salt, they are very much controlling with 100 gram per liter. The pure sodium chloride you can produce, but very rough and the mixture of the impurity. So they have a calcium sulfate, magnesium sulfate. So mixed all the salt can be combined, which means the taste is different. Also, their purity is different. So people, depending on the where is you are producing salt, it's not like that much simple as you have a natural way of the evaporation, like a ponding system to create your sea salt. So that's the how you have to think about to collect the useful mineral, and this is the sequence of a precipitation of mineral from seawater. So you can see how much they produce the percent of evaporate. The crystal, initially calcium carbonate, as we mentioned, and then 68% calcium sulfate and sodium chloride, magnesium sulfate, magnesium potassium chloride, magnesium chloride. So we have this level of the precipitation you can collect from your brine minerals. Also, so this is the way an extraction of magnesium. So magnesium is a very high concentration in seawater, and also you can easily separate because magnesium can provide 40% of magnesium what we are also producing. So this is the Dow process. The magnesium from seawater. So you just put the seawater sunlight, magnesium, and replace with the calcium hydroxide. So magnesium hydroxide can be produced. And then this magnesium chloride, you can have a 35%, and then you can also give this electrochemical process. So anode cathode, and then you have this chloride can produce the chlorine. At the same time, the cathode, you get the two electrons from this chlorine produced material, and then you can have a metal, magnesium metal on the cathode material. So based on this one, you can have a very good purity of the magnesium can be produced from this magnesium extraction. So that's how they are producing also bromine. So there are many people also extract bromine. So this is how the bromine can be produced. The bromine also we have very much valued in our seawater. So concentration is almost 100 milligram per liter. So you can use chlorine oxidation. So chlorine in aqueous condition combined with the bromide. So bromide will convert with the chlorine ion to bromide gas condition. So this two bromide also bromine to two electron, and then you can have also this kind of equation. So chlorine, you just put the chloride in your chlorine concentration in the seawater. So you will have this bromide gas condition. So when you have a bromide gas, so you can easily collect this gas from the stripping method, and then you can put into the bromide with the water, and then you have a liquid bromide condition. So this is the how you have produced your overall liquid bromide material. So you can have easily just put the seawater like a spray, seawater spray, and then you can mix it with the chlorine, and then chlorine combined with bromide, and then bromine gas condition. So gas will be produced for bromine gas, and you just collect from the gas liquid extraction method, and you have this kind of process to extract the bromine. Also, rubidium. Rubidium is used for very high precision laser for Navy, submarine, medical application. Rubidium quantum navigator for ships and submarine. So rubidium is $10,000 per 1 kilogram. So this is very high value. And then seawater contain 0.2 milligram per liter of the rubidium concentration. So you can collect this rubidium from seawater brine using this potassium cobalt hexacyanoferrite. So you have this material like a black color. You have a potassium and iron cyanide ferrite, and then rubidium concentration in seawater replaced with your potassium, because potassium and rubidium size are very much similar. So you can easily collect your rubidium concentration inside this KCOFC nanomaterial. So you have a very good way of the collection of this, and then you can regenerate this rubidium with the potassium. So potassium high concentration will be collected with this rubidium. So you can have a good concentration of the rubidium. So we can also extract the rubidium from seawater and lithium. And I don't want to talk about why the lithium is very important, because already you know that the lithium is becoming more and more important. Also, you can collect from seawater. So lithium concentration is very low in seawater, 0.4 milligram per liter. And then aluminum-based, manganese-based, and titanium-based material will replace with the lithium and hydrogen. So that's the we can have a selective lithium extract ion material with the lithium on sieving effect. So that's the how we look at the this is method. So you can see the lithium sulfate, and then lithium is inside your material, and then this is the lithium as hydrogen. So lithium compound can replace with hydrogen here, and then they can have a very high concentration of hydrogen, and then you can release the lithium. So it's like a ion exchange way of the replacement. So hydrogen and lithium can be replaced each other in this nanomaterial, which is aluminum hydroxide, ion sieving, lithium manganese oxide, lithium titanium oxide, and manganese and the titanium oxide. This material can replace with your hydrogen and lithium. So you can collect the lithium from the seawater, and you can extract higher concentration lithium from the seawater. So that's the how we have produced the lithium concentration in seawater. So your assignment. The primary how you can capture from your seawater desalination plant in Italy. Then what's the value you can calculate based on how much concentration you have, at the brine, how much you can concentrate, and then what's the technology you can apply, what's the best way you have brine mining function. So that's the your assignment 3. You need to cover from the external out one and how much this can economically can compare. Right? So that's the your assignment 3. What's the your perspective of brine mining in the future, right? And this is the what we have covered today. And tomorrow we can think about design together. So we have an example of something like that. Parameter design of so we have a capacity, cubic meter per day, TDS concentration, membrane property, operating parameters. So your assignment is more about seawater desalination in scenario, right? But this one is based on the wastewater reuse. Because I just want to give you an example how we can understand have when you have this capacity, what opinion, and how we can utilize the basic and the calculation and go next step of the computer aid in the software. So that's the what we like to do tomorrow. So tomorrow we have a computer room downstairs and from 12 o'clock, right? Yeah, 12 o'clock. So you can check your email because I sent you last few days ago. So you have a computer room, but as I mentioned, I don't want you to use computer room. Not really suitable for you to use when you sign the laptop. Your laptop can be used, as your assignment. Yeah. So I hope not everyone bring your laptop here. So if you are free, we can install your software. So you can get this. You have software in your you can download from the website without chemical, or I can upload in the campus. You can download from campus, so you can install it, and then you can maybe tomorrow you can go step by step how we can utilize. So making sure you bring your laptop, and then do not rely on the our computer because you have to finalize the decision. And then we will go for the example, this kind of simple example you can follow and we can do together. Then you will be much more confident to deliver the assignment independently for your scenario based. So that's how we like to do it. So we have covered today a lot of information from seawater desalination, reverse osmosis, water quality, as well as what's the current status of the civil digitalization, legal process. And there are many chemistry, like why we have to include chlorination, why we have to put some of the coagulation, also why we need to put some of the pH adjustment, what's the relationship CO2, bicarbonate, carbonate, and then post-treatment like CO2 remineralization, and this line addition, then reverse osmosis, what's the design, we can do that. So we need to based on this fundamental osmotic pressure, osmotic calculation, so we need to apply this concept to the real design. So tomorrow will be very much the real design practice. So we can have a more complicated practice of the real design. So any question for today is everybody is very clear. So you feel like more confident for seawater, what is it? Yeah, what it looks like in seawater. So previously seawater was just the seawater. Now you can see the seawater, what is inside, why this is important, and how this provides a lot of benefit to human life. So we have to very much appreciate this seawater. Yeah. So we will continue design of the seawater desalination tomorrow, and then hopefully we can maybe today we can start on your assignment. So we like to finish your assignment as soon as possible. So you don't have to worry about a lot of another assignment for different subjects, right? Maybe you can finish your assignment by this weekend. So tomorrow you finish, and then you just finish Saturday and Sunday. And then you forget about your assignment, you can focus on other, you have a lot of assignment, right? Other subject. So that's why I'm sure that most of students, they are very busy at the end of the semester. So like they complain on too much and extension. So I'd like to give you the freedom within this week. Then submit, then you'll be very relaxed for the rest of the semester. That's what I want from you, right? So please follow me. Then you will give extra point if you submit by this Sunday. Okay. So if you don't have any question, we will check out something. Yes. You need to register. So we sign it. Sign it. You need to sign it. Then we can slowly.
I signed it, yeah.
So you need to, they need to approve it. They need to approve it. It's not like you sign and you don't get to. They check your, it takes time. That's why I can give you from the canvas. And you can download it's fine. Well, it's done any time. It takes time. They will also.
think about the content as well. So I enjoy that part. Yeah.
I have another, another side of the problem.
It's not window. It's for window, both mechanisms and you have, you can select the, but one of them.
I found the, not, yeah, I actually came to some of the videos, I can.
And it's on A, A. Computer, well, that's right. Let's try.
We just set up, we've got like an external workshop coming.
External workshop.
We just set up.
Yes, you can, we just finished, I just finished.
I
Okay.
know, I know.
Just a second.
Thank
Yeah,
you.
we
Just so
just finished.